And we're live. First lesson of the year. And I always start out with lesson 1, what is physics? A lot of you signed up for it, but if you ask, in fact, I started teaching physics in 2002. And my mom asked me, so Kelvin, what's physics? You're teaching it. I'm going to give you one definition that my physics prof gave me, and it's a pretty good definition. My physics prof always said that physics was the science of measurement, which really means that anytime I'm calculating or measuring something, I'm doing physics, which really means a lot of stuff comes under the definition if I use that definition, like pretty much everything can. But it also leads to an obvious question. Okay, if physics is the science of measurement, what do we measure? What do we measure? This year, there's the big 3. We're going to be measuring length in. Does anybody know what are the fundamental SI standard units for length? Take a guess. More specific, what are the units for length? We don't use imperial, that's the US. Sorry, you're right. Meter. Yep, meters. M. By the way, meters in Canada is spelt R-E-S, not E-R, but I don't care. I'll do both in flip-flop, but. Another big one. Time. This one you probably know. What are the fundamental base units for time? Not hours, not minutes. Seconds. Oh, and by the way, I tend to abbreviate. That was a joke there. I even abbreviated the word abbreviate. Come on! No? Okay. And mass. What are the fundamental units for mass? They should be grams, and they're not. And the reason is a gram is just too stinking small. So actually, this is the only one, kilograms, where we actually put another metric prefix in front of it. It's the one that doesn't quite fit in. But these are 3 of the fundamental. In fact, there are 7 fundamental defined units in physics, in science. Everything else is based on those 7. The units used are what are called SI units. It's French, it's System International. You sort of call it the metric system, but really it's more than that. So the base quantities are length. I already gave you that in meters. What were the units for time? Seconds. What were the units for mass? Kilograms. Now, you will learn other units this year. You'll learn about newtons, but actually a newton is a kilogram meter per second squared. It's actually made up of those 4. You'll learn about impulse, but that's actually kilogram meters per second. You'll learn about joules. Joules are Newton meters, which is kilogram meters per second squared meters. Everything is made up of these 3 this year. Next year, if you take Physics 12, we'll also do some electricity, current, which you also did in Science 9. Does anybody remember what the units are for current?
Watts.
Watts? Actually, power is measured in watts. Or as I like to say, power is measured in watt. And then my students all laugh and giggle and say, watts. Good guess, though. That's power. By the way, power is defined in terms of current. Nope. So now we're down to one more. Yes? Amps. Amperes, but amps for short. So let's write that down. Amps, symbol for that is capital A. If you want to, you can make a little note right here. Put a 12, Physics 12. Here, Physics 11. And then there's 3 more that we don't look at in high school physics. But I'll give them to you because I'm a nerd anyways. Temperature. Does anybody know what the fundamental units are for temperature? I'll give you a hint. It's degrees, but there's a certain temperature scale that we use in physics. It's my favorite unit. Yes, Kelvin, which is my first name. I'm actually a scientific unit. Degrees Kelvin. sometimes written degrees and a little k. Although I think because it's the standard de facto unit, if you just put a degrees sign, you're supposed to assume it's in Kelvin because that's what nerds would do anyways. The amount of a substance, this is chemistry. You may have seen it, especially grade 12s if you took Chem 11 last year. Anybody know Mr. Perugia has that big cube hanging from his ceiling, that cardboard cube? Okay. Moles, symbol MOL. And then the last one here, it may be my favorite because as soon as I tell you this unit, you'll know exactly how big it is. In other words, if I say to you 1 meter, unless you've seen a meter stick, you don't know it's about this big. If I say to you 1 kilogram, unless you've kind of mucked around with some masses, you don't know how big a kilogram is. But when I give you the unit for light intensity, you'll know instantly how big one is. Does anybody know what we measure light intensity in? Candles. And now you know exactly how big 1 candle is, don't you? Yeah, that big. Exactly what you're thinking of, 1 candle. It's actually candela. Okay, fair enough. Candelas. Symbol Ca. But those three I'm not putting a number next to because we're not going to use them. In fact, you're not going to use them in high school. You might in moles you use in chemistry, and you might use some of the other ones in chem, but not in physics. Okay. In addition to base units, oh, hang on. Put your pencils down. I think I have a video to show you here. And this is where you're going to want your formula sheet out. In fact, you're going to want the back page of your formula sheet, I think. I wrote this, in addition to base units, the SI, the System International, I'm just going to say the SI, uses a prefix system to allow for the expression of large and small quantities. Of large and small quantities. Whoop, wrong button here. Lost my whole ribbon. Where'd my ribbon go? Try that again. So, for example, 2.5 kilograms, you can replace that K with, well, look at the green sheet on the back. What can you replace the letter K with? You can see there's a chart, top right corner, I think. Is that where I put it? I think, yeah. You do not have to memorize these. Don't memorize these. Now, you might memorize a few of the more common ones because you get sick of looking them up. Mackenzie and Mackenzie, that's the only reason you should memorize stuff, because you get sick of looking it up. But you don't have to. What can I replace a lowercase k with? 10 to the what power? Read across. 10 to the 3 or 1,000, whichever is easier. So I can replace that with 10.5 times 10 to the 3, and then I just repeat the grams, the base unit. The prefix kilo means times by 1,000 or times by 10 to the 3rd. So we're going to complete the chart below in our notes. This is just so you know where they all are on your formula sheet. We're going to start actually here in the middle where it says base unit. This is going to be grams or seconds or meters. Now the problem with meters is a lowercase m is meters and a lowercase m on there is milli. So you have to look carefully, is the lowercase m at the end of the unit or in front of something else? Sorry, we only got 26 letters in our alphabet. You're going to find we have to reuse some. Grams, seconds, meters, oh, and then like amps and newtons and all, but I'll just do those ones for now. Okay, so this just means you multiply by 1. Really, it means you don't do anything. You just use the number. But if you want the multiplication factor, times by 1. Or if you want to write it as a power of 10, 10 to what power is 1?
0.
Yeah. Okay. We're going to go down. We're going to get bigger. Deca. What's the abbreviation for deca? I don't know because I haven't memorized it. Read it, please. Someone? Anyone? DA, lowercase or uppercase? Because it makes a difference. All lowercase, DNA. Thank you. And I think that's you multiply by 10 to the 1 or 10. Asia, I'll be honest, I never use that. I am not going to say 5 decameters. I'm going to say 50 meters. Less writing, and that is a number I can still wrap my brain around. And that's why I honestly didn't know the prefix for, I know it had a D in it, but I couldn't remember whether it had the A or something else. The other one I hardly ever use is hecto. Prefix, is it lowercase h? Just an h? Okay. And I can replace that h with a 10 to the what? Or as a number, 10 squared is? 100. It's easier for me to write 10 squared, and I tend to abbreviate. So you can write 100 if you want to. I'm going to go short. The reason I don't use that, you know what? I'm not going to say 4.5 hectograms. I'm going to say 450 grams. Because that's a number, hundreds I can still wrap my brain around. Kilo. This one you'll probably end up memorizing because most of you are getting your licenses soon. Kilo, symbol K. Kilo means what? Anyone, it's on your chart. 10 to the, yeah, or 1,000. You'll memorize that one because like highway exits and things, when it says 1 kilogram, you'll also think, oh, 1,000 meters. You get good at that one. You can also have kiloseconds, that's 1,000 seconds. Mega. Uppercase M or lowercase m? Uppercase? And I think now we start going up by threes, don't we? Isn't now at 10 to the 6th? Mega is a million. That actually, when I was in high school, is where I tended to stop. When I was in high school, I got my, actually not when I was in high school, when I was in my first year of college, I got my first ever hard drive on my computer, and it had 8 megabytes. And I remember thinking, how will I ever fill that? 8 megabytes, that's massive! That was my generation. Mega was as far as we went. In fact, even 5 years ago, I had to extend this chart about 5 years ago because you're already getting bigger numbers. Now we're going to keep going. After mega comes giga. Capital G, yes? Giga is 10 to the 9. Or a 1 with 9 zeros. Are you seeing why I prefer the exponents? A billion, if you really, but I just giga 10 to the 9th. Now hard drives are given in gigabyte storage. No, hard drives were given in gigabyte storage 3 and 4 years ago. But already 3 and 4 years ago, we tipped. And now we have tera. Capital T. 10 to the 12th? Yeah. I have a little external hard drive sitting right here. It's a 1 terabyte hard drive, which at the time was, wow, really big. Now there's 2 terabyte, 5 terabyte. I mean, they're getting bigger and bigger. In fact, now I'm just starting to see peta. Google's servers are in the peta range. Peta is what? Is it on your chart? Capital P? 10 to the 15th? Okay. I'm willing to bet that by the time you finish college, become part of your vocabulary, and I'm willing to bet by the time you're in your 30s, the next one will be out there too. Exa. I added this one 2 years ago because I figured it's just around the corner. What, capital E, is it? Okay. And it's 10 to the 18th. I haven't actually come across that one yet in literature, but it's only a matter of time before someone somewhere has something that big. Did I say big? Let's go smaller. Let's go up this way. Deci. And this is why deca and deci, I always get them mixed up. And I know they both have D. What's the abbreviation for deci? Just a lowercase d period? Okay. So a decimeter, decasecond. And it's, now it's either, you can write it as 0.1, but we can also start to bring in negative exponents. 0.1 is the same as 10 to the negative 1. And you know what? Since we're going to be getting smaller and smaller decimals, and I like to abbreviate, I'm going to go with the exponents. I never use that though. I'm not going to say 5 seconds. I'm going to say 0.5 seconds. That's what it is. And that 0.5 seconds, all of you go, oh, half a second, you know what that is, as opposed to 5 deciseconds. What the heck is that? I'll go do a conversion. Yeah, forget it. I do use centi. Where do we use centi? What measurement? Centimeters. Okay. So I know that one I've memorized over the years. I know it's a C. And I know it's 10 to the negative 2. I know 100 centimeters is 1 meter because I've held meter sticks and I've read them. Nerd that I am. Heck, I even know that 1 foot is about 30 centimeters because I've held rulers and I've read them. Nerd that I am. Milli, lowercase m, yes? That one we use as well, millimeters. 10 to the negative 3, or 1,000th. So a millisecond is 1,000th of a second. Okay. And now we'll start to get into some you may not have seen. Micro begins with M, but we've already used M for milli, and we've used big M for mega, so we're going to use a Greek letter M for micro. It looks like this. Oh, you know what it looks like? Looks like this. It's called the Greek letter mu. It is where we get our M from. So, micro, like that. It's sort of like a U lower with a long tail, mu. What does a Greek cat say? Mew. What does a Greek cow say? Mew. There's all sorts of stupid jokes along those lines, right? Micro, you probably won't memorize this year. Micro, you'll end up memorizing next year when we get to electricity, because we typically measure coulombs in microcoulombs. You might recall learning in Science 9 that charge is measured in coulombs. If you had me, I told you in Science 9 that 1 coulomb would fry you, would kill you. 1 coulomb is a huge amount of charge. So microcoulombs, that's usually what you're getting if you get a spark when you touch a doorknob or something like that. So you typically in Physics 12, you will end up memorizing micro. I have, because I've taught Physics 12. I know that one. It's 10 to the negative 6, yes? Yes, 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 yes? Yeah. Do you have to memorize them though, Casual? No, you'll have this sheet whenever you're doing your homework or on your tests. And then you guys are part of the whole nanotechnology group. You hear that all the time. So nano, lowercase n, yes? 10 to the negative 9? Yeah. Or 0.0000. Use the exponents, it's way easier. Okay. I think when you're talking nano, now you're getting large molecule sized. Pico, you're getting even smaller. Pico, lowercase p, yes? 10 to the negative 12, I think. Because I think now it just goes up by 3s. Femto is it a lowercase f or a lowercase fe? Just an f? 10 to the negative 15. And then I don't know if this next one will happen in your lifetimes, but F has already. In fact, I'm going to show you in a couple of minutes a video of a femto camera. Atto is lowercase a, and 10 to the negative 18. Do they go small? Yeah, they do. I just haven't bothered looking them up. I'm sure that I could find them online somewhere. Let me emphasize again, Mackenzie squared. Do you have to memorize these? No. Can you? Sure. Will you? You'll probably memorize a few of them because you get sick of looking them up. It's the only reason you should memorize something. Any base unit can be used with a prefix. For example, 1 kilogram, I can replace it with a 10 to the third, or if I go to my calculator, it becomes 1,000, and then I just add on the G. 1 centimeter, well, how do I go from 1 meters to 100? Well, 100 centimeter, I would replace that C with a 10 to the negative 2, and if I go 100 times 10 to the negative 2, if I actually multiply them, I'll get 1. In other words, you can replace these letters with that 10 to the, and then just multiply by what's in front on your calculator, and you're good to go. During this course, we will use models. Yeah, next page. Often mathematical, to help us understand a particular set of phenomena, stuff. But I have to start out always, Leah, by telling you these models will almost always be partly wrong. I'm going to lie to you a lot. But you know what, Kyle? There'll be good approximations. We'll be close. We'll be close. And I will try and tell you when I'm lying to you for the sake of mathematical convenience and pretty physics as opposed to going all the way down to yuckier physics. Okay. Since our models will be mathematical, good math skills are a must. Here is a review of the basics. Put your pencils down.